All right, we're doing Algebra 2 Semester 2, 3.7. I believe this is going to cover the second quiz of this section, so I believe it's going to be 3.74. I am on page 15 of the 3.71 study guide. So, relationship with logs. If I see logs with addition here, I know that becomes multiplication. Or if I have multiplication with a log, it becomes addition, assuming the bases are all the same. If it's subtraction, it's division. So assuming the bases are the same, I can just take the numerator, it goes first, the denominator goes second, or take the second, it becomes the denominator, take the first, becomes the numerator. We can go left to right, right to left. Um, if our argument of our log, so where the a is, if it ever has an exponent, in this case d, we can take the exponent, put it in front, and multiply it. So the log stayed the same, log base b of a. I just took the exponent from the argument and put it out in front. The last one is anytime I have an argument of 1. So an argument of 1 means 0 every time. So anytime you see the argument of is 1, doesn't matter what the base is, doesn't matter what anything else is, argument of 1, everything's 0. Alright, so let's knock out a couple examples here. Again, I'm on page 15 of the 371 study guide. So this is log 16 minus log 4. Alright, so I see subtraction, right? So to me, subtraction means division. I see subtraction, I think division when I'm thinking about logs. There's no base listed, and that's okay. Because if we have no base listed, we call that the common log, and we know the base is 10. So I can just go ahead and write log. And I know 16 of 4 is going to be, well, 16 is my numerator, 4 is my denominator. Because of the subtraction, I knew this was going to be division. And I can simplify this further and just say this is log of 4. So that's my first example, and I'm done. Alright, so page 15, example 2. Alright, so I have log, oh, and this is something that we actually didn't talk about, and that's good. Not sure how I missed it. Alright, so for this problem, anytime I have a base and an argument that are the exact same. So I have a base and an argument that are the exact same. So anytime you get this scenario, that's going to be equal to a 1. So I have 1 plus log base 5. Now, with the same knowledge I just dropped, we'll say, drop some knowledge, argument and base are the same, it becomes 1. So I'm going to kind of manipulate a little bit. So for this problem here, I'm going to change this 25 to be a 5 squared. And then I'm going to take that square, that exponent, I'm going to put it out in front. So this is now going to be a 1 plus 2 times log base 5 of 5. And we kind of just talked about it. We use reverse color now. Anytime we have the same base and the same argument, they cancel. It becomes 1. So this is 1 plus 2 times 1, which is just going to be 1 plus 2, which is going to be 3. Now, just to show that we can do these multiple ways, I'm going to rewrite this problem. I'll save it. I'll solve it, excuse me, another way. Because logs give us, usually we have a couple options. There's always a best way. Usually there's a best way. Alright, so we have the same exact problem. Now we have the same base here. So we have the same base, and we have plus. So what this tells me is that we're going to multiply 5 times 20. Ooh, that's the worst 5 I've done. 5 times 25. Alright, so this is going to be log base 5 of 125. So this is an acceptable answer, right? That's the same number simplified. I could even do this. Log base 5, well 125 I know is 5 to the 3rd power. I can then take that exponent, put it out in front. Oh, there it is. We have a base and argument that are the same. So this is 3 times 1, which is just equal to 3, which is the same answer we got on both sides. So the reason why I did it twice is just to show you that I started one way or I could start the other way. It didn't matter to me. And there's a couple different ways you could solve it, and we got the same answer both ways. And it's possible if there's like a multiple answer type question, you could have log base 5 of 125, log base 5 of 5 cubed, 1 times 1 plus log base 5 of 5 squared. You know, any of these could be a piece. It could be a multiple answer question. So keep that in mind that there are multiple ways to do this. All right, let's go to the next question. Again, I'm on page 15 of 371. So we have the natural log, which means base e squared. All right, I have this exponent, so I'm going to put it out front. This is 2 times natural log of e. Now, what's the base of natural log? Well, we know the base is e, so we know that this is a base of e, and we know the argument is e. Well, that cancels. That's just a 1. So it's 2 times 1, so my final answer is 2. So we were able to pull that exponent out front because we know the natural log has a base of e, and the argument was e. They cancel. Anytime you have the same base, the same argument, they cancel. And that becomes 1. 2 times 1 is just 2. Alright, moving on to question 4 on page 15 of 371. This is the last one. We have log base 6 of 1 plus log base 5 of 216. Well, I have an argument of 1. What did we talk about that earlier? This is automatically 0. So we have 0 plus log base 5 of 216, so I can just kind of cancel that of 216. Cool. And that's going to be it. That's going to be us simplified.